Okay, so let's look at this next example. We have 3 different transformations, so we're going to take them one at a time. First, we have the triangle. Now, what has happened to the triangle? It's been flipped over, and a flip is called a reflection. There's no other option for this one. That's the only way to get this triangle in the pre-image, remember that's what we call it, to look like the triangle down here in the image. Now, is it distance preserving? So common sense, I'm going to ask myself, well, are they still the same size? Yes. Is that good enough for me to put yes? No. I have to actually prove it. So I'm going to measure it. If you have tracing paper, you can trace it. You can trace the pre-image and then just move it so that it lines up with the image. And if it's exactly the same, that is also a great way to tell if it's distance preserving if you don't have something to measure, or it's just hard for you to use a ruler. If you don't have tracing paper, honestly, lined paper is see-through enough to use, okay? So use whatever tools you have. I went ahead and labeled 2 points, A and B, and I'm measuring with my protractor using the millimeters function, and this is 2.4 millimeters. Down here in the image, it's been reflected, so A prime is actually down here, and this is B prime, and it measured the same thing, 2.4 millimeters. So is it distance preserving? Yes. Next, for this parallelogram, what transformation? It just slid down and to the right, so I see that that is a translation. Distance preserving? For me, common sense says no, because the image down here is smaller, but now I have to prove it. So you can trace one of them and try to line it up with the other, and you'll see they don't fit. But I'm just going to go ahead and label this A and B. And when I measure it, I get about 1.9 millimeters for the pre-image. And when I do A prime and B prime, I only get 1.4 millimeters. So this one is a no. Okay? So this is not a rigid transformation. It was transformed, but because it got smaller, then it's not rigid. Rigid means it stays the same. Okay? Now we have this like double-sided arrow type shape. What is the transformation? It was turned. A turn is a rotation. Is it distance preserving? Common sense question. Looks to be the same size, so I want to say yes. I'm going to measure it or trace it, whichever one you prefer or have access to. I'll call this A and this B. Why I chose that spot, I don't know. You can measure any 2 points that you want. And this is right about 2 millimeters. Need to measure the same place, A prime, B prime. It's still 2 millimeters, so I can put yes, it's distance preserving.